Okay, today we're going to take a look at types of discontinuity, so let's begin. The learning goal. Students will be able to identify types of discontinuity. I know this seems weird, but if we know what's discontinuous, we know then what would be continuous. So bear with me here. I like this video because there's a lot of pictures and showing you what discontinuity looks like. There's not going to be a ton of me doing analytic examples. So first off, what makes something continuous? Continuous functions have no breaks in the graph, no holes, no jumps, no asymptotes. Basically what they make is a wonderful roller coaster. So if I was on this roller coaster, oh yeah, look at this thing. Woo! It would be nice and fun. No breaks, no jumps, no holes, no asymptotes. Now in terms of the four types of discontinuity, okay, what is not continuous, the first one that we're going to look at today is called jump discontinuity. Basically I'll run through it quickly now and then I'll show you a picture. It means that the limit from the left and the limit from the right are not the same height. And you'll see what kind of discontinuity that'll create. It's called jump, so you can guess probably there's going to be a jump in the graph, but we'll see a picture in a second. The next one is called point discontinuity. It means that you have basically a limit approaching a of a function, and you have a hole there, but you still have a point that exists there. So the height's still there someplace, but it doesn't fill in the hole in the graph. The next one would be removable discontinuity. So f of a is not defined, meaning you have a whole period and you don't have some order pair someplace like in example 2. And then number 4, essential discontinuity, one of my favorites. You have a vertical asymptote. Okay, so let's see what these things look like. Let me grab another color here, like yellow. Okay, jump discontinuity. So basically, a jump discontinuity occurs when the curve breaks at a particular place and starts somewhere else. Okay, so in English, this is what's happening. You basically have the limit from the left and the right not matching, and notice here, to get on from this graph to this graph, we would have to just jump. So that makes this not continuous, and this would be a horrible roller coaster, by the way. It might be fun for some of you guys, but just think, you just kind of go right down there. Not too much fun for me. Let me grab another highlighter color here. Let me grab Mr. Green. Okay, point discontinuity. Basically what this is, a point discontinuity occurs when the curve has a hole in the form of a missing point. Now, so let's check this out. We have the limit as x approaches a of f of x is not equal to f of a. So I have some ordered pair, but it doesn't fill in the hole that I have. And so just imagine going on this roller coaster. Straight down. Not so much fun. This is a form of discontinuity. So it's called point discontinuity. It makes a lot of sense. You have a point that's missing and it's someplace else. And this notation, by the way, is going to be very helpful for the future, especially when we prove something isn't continuous or is continuous. Okay, so the next one is called removable discontinuity. So removable discontinuity, a removable discontinuity occurs when you have a rational expression with a common factors in the numerator and in the denominator. This causes a hole in the graph. So basically, if you can factor your function and you can cancel stuff out, you probably have a hole that occurs. That's what this says. Now, this is different than the other one because f of a does not exist, meaning we don't have an ordered pair someplace. You just have a hole. And this makes for a very lousy, once again, roller coaster. Alright, the last type of discontinuity that we're going to look at is called essential discontinuity. An essential discontinuity, so let me highlight that for you, occurs when the curve has a vertical asymptote. Now remember, to have a vertical asymptote, let me grab Mr. Green, you have in the denominator, so let's say I have 1 over x, you have some number that you can put in for the denominator that will create 0, that's 1 over 0, and so I know I'd have a vertical asymptote at 0. So just to recap, scroll all the way back up. We have four types of discontinuities. The first one is called a jump discontinuity. It looks a little something like this if I sketched it really quick. So you would have to jump from one graph to another to get there. So that's called jump discontinuity. Let me grab Mr. Red here. Point discontinuity would look something like this at A. We have a curve, and then we have a hole, and then we have a point someplace else. So that's point discontinuity. Let me grab another color here. Blue seems like a good color to me, so let me grab it. Alright, and for removable discontinuity, you have a hole again at, let's say, some location A, but it's no order pair to be found, so that's this one. And then the last one, my favorite, so I'll grab, in this case, another color. Let me grab black, and in this case, if I scroll down a little bit, essential discontinuity is I have a vertical asymptote. So that's the four. If I scroll all the way back up to our learning goal, students will be able to identify the four types of discontinuity. I do think you'll be able to do that, and I'll see you on the next video. Thanks.